This is a good problem to help you understand how to interpret and read different kinds of word problems. So let's just take a look at it and see if we can understand what the problem is asking first. So it says, suppose that a piston is moving straight up and down and that its position at time t seconds is defined by this function. So the important thing to see about this right now is that we have a function. Our y value is s, and it is a function of the variable t. It is a function of t seconds. The 2, the pi, the b, and this a are all constants. The only thing that is changing in this function here, and this is important to be able to see, is s, which is the position of the function, and t, which is the number of seconds that are going by. So s is a function of t. And that means that a, 2, pi, and b are all just constants. So we're told that a is the amplitude, b is the frequency, well, 2 and pi are just numbers, right? And it's asking the question, what effect does doubling the frequency, so if I want to double b, what is it going to have on the piston's velocity, acceleration, and jerk? Well, we remember that s is the position, s prime is velocity, s double prime is acceleration, and s triple prime is jerk. So we'll probably just carry this problem through velocity, maybe through acceleration, and you'll see how it plays out. But again, reading the problem, we're looking to find out, well, what effect does it have on, as soon as we see velocity, acceleration, and jerk, and we know we have here position, we know that we have this order here of derivatives. So this is a problem where we're just going to use to take derivatives. So I've rewritten my function here, and if I want to find the velocity, I need to take the first derivative. So I'm going to go d with respect, sorry, wrong letters. I like to use this form, this notation. I'm going to go d with respect to t, because t is the variable here that I'm working with, of the function s is equal to the derivative with respect to t of a times cosine 2 pi b t. Well, I know that this is a constant, this a, so I can just pull it, I can pull it through the derivative. Remember that? So it's going to be a times the derivative with respect to t of cosine 2 pi b, and I'm going to make this t a different color right now, because so then you can just kind of see that that is the variable that I'm working with, and this 2 pi b, I could just call it 2 pi b. It's just a constant. It's 2 times the number pi times some number b. So I get the derivative is equal to, let's get a nice color here, I'll go to red, is equal to a, now the derivative of cosine is negative sine, so times negative sine of 2 pi b t times, because I got to use a chain rule, times the derivative of the inside here, which is just going to be 2 pi b. So because it's really, what I'm looking at is the function 2 pi b t, and that's t to the first power rule, 1 times 2 pi b, and it makes it t to the 0, so I'm just left with 2 pi b. So this is the first derivative, this is the velocity, and I think I ought to simplify it just a little bit, since it's times 2 pi b, and I have an a, and I have a negative sign. I'm going to call this negative a 2 pi b times sine 2 pi b t. So that would be my velocity. So let's mark that, we'll call that S prime. So I'm going to find my acceleration. I need to do S double prime. So S double prime, that's going to be the derivative with respect to t of negative a 2 pi b times sine 2 pi b t. I want the derivative of that whole thing. And just like before, a is a constant, 2 is a constant, pi is a constant, b is a constant. I can pull that entire constant through the derivative. So it's equal to negative a 2 pi b times the derivative with respect to t of sine 2 pi b t, and that is equal to negative a 2 pi b times, well, the derivative of sine 2 pi b, the derivative of sine is cosine, so I have cosine 2 pi b t times the derivative of the inside, which we already did, is just 2 pi b. So simplifying this, I have it's equal to negative a, then 2 times 2 is 4, pi squared b squared cosine 2 pi b t. So again, let's just identify that as S double prime, or let's make sure we know this is our acceleration. Let's actually put it over here next to S double prime. We'll call this acceleration, and we'll call this, look, where's our velocity was right here. It's right in red, consistent. So I think you could do the same thing going on to jerk, another iteration of this same process here. But let's go back and answer the question. It says, what happens if I double the frequency? And frequency is b. B is the frequency. Well, if I double the frequency, then my velocity here, my velocity right here, if b has been doubled, then the entire velocity here is going to be doubled. So it's going to be times 2. Because this is a constant. It's the constant of this whole term. I double that, I'm just doubling the whole term. But my acceleration, if I double b, if b was 2b, then I have 4, well, I have, then I want to think this through here. So I had to pause there for a second. But if I doubled b, I have an exponentially larger coefficient here, because I'm not just doubling b, I'm doubling b and then I'm squaring that. So this thing here, the acceleration, is going to be increasing exponentially every time I double the frequency. Now, I don't know if you can visualize a piston, but if my velocity of the piston is doubling and my acceleration of the piston is like maybe quintupling, that thing is going to be going like 1,000,000 miles an hour, and the motor is going to burn out. So the main thing with this problem, I think, though, is recognizing how to see this kind of a term right there as just a constant and treating it like a constant, as opposed to getting all freaked out by the fact that I have an A, that I have these letters there. The only variable, so to speak, this is a function with respect to t. It's not a function with respect to A or B.